Hi, my name is Dandrea, and today I'll be covering oxidation and corrosion and how it affects copper pennies. Here is the summary. Background information. Copper, corrosion, and oxidation basics. Oxidation can cause a copper wire or a copper penny to grow patina, which you can see down here. Corrosion is the deterioration of a metal, which can also be oxidation. Chemical, the chemical formula for oxidation is right here. One example is oxygen and moist air to copper, which is this down here. Oxidation itself is a chemical process where the metal becomes oxidized through the process of an electrochemical transfer of electrons from one thing to another. Another way it could happen is the process between the metal and another substance when an electrolyte is present. Alloys and their properties. Brass can be used in construction for roofs, heating, plumbing systems, and the skeleton of a building itself, its infrastructure. Bronze is stronger than both tin and copper separately because the sizes of the two different substances are different, one's bigger and one's smaller, and when both metals try to slip by each other, they cannot, so that makes them tougher than each of them separately. Bronze is also easier to cast into molds than copper on its own. Finally, there is something called a mono alloy, which is made from nickel and bronze, which is more resistant to rusting. Some other uses of copper include pesticides, additives for farm animals, and fireworks for the bright emerald green color, among others. There are many ores that can be mined that are used for compounds and everyday materials. A compound could be used in pesticides, which include basic copper acetate. Another thing that it is found in is turquoise, which can range from blue to green, and malachite, which are semi precious gemstones made from copper compounds. Some other uses of copper include electrical devices such as electric clocks, stoves, portable CD and DVD players, transmission, and electrical wiring that carry electricity. How it is mined? Copper is mined with a large track mounted drill, which is then broken into pieces by drilling and blasting, and then hoisted into a shaft and conveyed to a processing plant. The copper will then be extracted from the waste constituents like the limestone and pyrite it was found in, which hold the copper in its veins, which is then melted down to remove the impurity elements. The last traces of impurity will then be removed from the remaining copper and produce a copper product, likely in a bar of 4 nines purity. For the future, this information is important because oxidation can ruin these copper products that use it in many ways. For example, oxidation can interfere with the flow of electricity through copper wires. Also, a copper product value can be decreased if the oxidation process occurs. Removing it would fix these problems and eliminate the cost of replacing the copper. This applies to electricians who need easy and cost effective replacement wires. If they could easily fix these problems with the ease of cleaning up the copper, it would last much longer and could help lessen the chance of needing to replace the copper. This could preserve the global copper supply. It would also give less of a need for recycling copper or throwing it out because there will be less to have to do that to both too. My questions. Well, I had two, and the first one was, what cleaning product does the best job of removing oxidation and corrosion from copper pennies? And then, how can this information be useful in the real world? My hypothesis. It is believed that tarnish less oxidation remover will do the best job of removing oxidation from copper. The information on oxidation works. The information on how oxidation works helps to answer the question by explaining what could be the best method of removing it. It also shows what copper can be made into and why is it useful in everyday life. It will be an easy and inexpensive method of preserving copper in many items longer than the average shelf life of the copper normally. I've used quite a few materials. You may read them, but the important ones you really need to know is water, oxidation and tarnish remover, and the method cleaning spray as well as the water. You also very much need the pre-oxidized pennies. As you can see, there are brands on the board, and those are the exact same brands that were used in this experiment. For each independent variable, which includes the method cleaning spray, the vinegar, and the oxidation remover, 2 tablespoons of each will be needed, and 3 pennies per bowl will be needed, and there are 4 bowls. The rating system. As you can see, the rating system was made as it is, 1 being the least dirty and the most clean, and 6 being the most dirty and the least clean. All coins, all copper pennies, had to start out with a 6 and then were graded on which side on the scale they were for after the experiment. Experimental setup. The independent variables, as mentioned before, were the tarnish and oxidation remover, method cleaning spray, and vinegar. The dependent variable was the pre-oxidized copper pennies. The constant variables are water, which was the control of the investigation, the temperature, and the humidity of the room. 3 pennies will be placed into 4 different bowls with 4 different variables, as seen above. They will be placed in a tray where they will stay for the time they are soaked in the liquids. They will stay in the same spot for that time. So this is a video of how this would normally work. 12 pennies will be selected from a large grouping that you have gathered together, as long as they're all graded 6. 3 pennies will be put into 4 different bowls each, so 4 bowls will have 3 pennies in each of them. They will sit in there for about a day, and then they will be cleaned off with water and a sponge or paper towel, as you can see here, for 15 seconds. And then they'll be cleaned off with a wet Q-tip for another 15 seconds, as shown here. This was used with only water, so that's the control of the experiment, and thus did not do very much. These are the results. This is the penny ratings change over time. So the first penny of water had no change, so it was given a 0. The second penny of water changed from a 6 to a 5 over time, over the entire experiment, so on and so forth. Here's our graph, and it shows that vinegar had the best change average rating over time. These results show that the vinegar was the most well suited for the cleaning of copper. This proves the given hypothesis wrong, because the hypothesis said the tarnish and oxidation remover was the most effective for the task. It is believed these results came out the way they did because vinegar is very acidic. The tarnish and oxidation remover is made for both removing tarnish and oxidation, and not solely responsible for removing the oxidation. This means the tarnish and oxidation remover was not the most well suited for the cleaning of oxidation from copper. Some error sources. The rating system and how the data was analyzed. A rating was made with the ideas of what seems the dirtiest to the most cleaned off. The rating scale could have been specified more depending on the coin, and there should have been multiple people scoring the coins. Another error that could be fixed is how the data was analyzed. The data should have been analyzed before the soaking according to an average of each coin honestly, and not just a biased opinion, and not trying to say they were all evenly rated with a rating of 6 beforehand. Similar sources include, otherwise, the data should be recorded as accurately as possible, with multiple unbiased opinions who have collective knowledge and experience on the topic of the investigation. These opinions should have been done with people who have expertise in the field of investigation and should have known how to either rate a penny previously or had an idea on how to rate a penny via their oxidation coverage. Moving forward, testing which kind of vinegar that is best suited for cleaning off copper should be an experiment in the future for future further help the effectiveness of cleaning copper and keeping it cost effective as well. A new hypothesis promoted towards this experiment is because of the acidic properties of vinegar, which would do the best job of cleaning off copper, of oxidation from copper. This experiment should also be tested with other independent variables that have some form of acidic properties or are made to clean off oxidation or tarnish. Each experiment would further help finish the goal of finding the most inexpensive and most effective everyday oxidation remover. It would also find a new reason to reuse copper, which would be recycled back into items that need it. Some applications. This experiment was intended to help the electricians of the world find a cost-effective way to fix copper wires that have decayed or been oxidized over years of weather and decay. This, this new information can be applied to decaying and ruined pieces of copper wire that have been corroded and oxidized to revert them to normal in the most effective way possible. This would allow more of Earth's natural copper resources to be stretched until they can't be used anymore, and thus keep this resource plentiful for many years to come. This would help technicians of the future keep electricity running for many years without having to worry about them needing to be replaced with more copper. This would also allow copper to be used in other electronics like computers and not wasting more of Earth's natural resources. Given more time and unlimited resources, a question the work could lead towards is how does vinegar break down oxidation and a patina on copper? And then some potential research the work could lead toward is how copper could be used for different purposes with the excess supply of copper from the possible implementation of the results of my experiment into the real world. Other research the work could lead towards is how industrial chemicals clean off copper versus the household chemicals and everyday cleaners. It could also lead to the preservation of Earth's natural copper supply and not drain it in 50 plus years when all the copper has been taken and used from Earth. We're excited. Thanks for citations. And thank you.